You know what's better than a 250K sub celebration? Nothing, at least in the world of podcasting. Come along today, we're going to talk about the questions that are most mesmerizing to you, my most munificent, magnificent, and brilliant audience members in the known multiverse. I'm Brian Keating, the Chancellor's Distinguished Professor of Physics at UC San Diego, and I'm so delighted to get to do this episode, a 250K subscriber celebration. I solicited questions on YouTube, Dr. Brian Keating, Instagram, Twitter, X, and Threads. Blue Sky, no, I didn't. Or Mastodon. Mastodon has been put out of existence again. Double extinction for that type of fat elephant. But it's really quite a joy. And actually, we have about 320,000 subscribers if you include all the folks that listen only on audio, which is fine to do. And I sometimes do that as well with other podcasts that have video channels. But this is specifically for my followers on the video platforms. And we've been having such a huge run-up. Even in just a week or two that I published requests for questions, we've gotten another 3,000 or 4,000 subscribers. So this is really a delight, and I can't believe I'm so lucky I get to do this and share this ride through the universe with you. So without further ado, let's get to some of the questions from you. First comes from Busy Billy B 33. Congrats, Dr. Keating, on yet another milestone with many more to come. My question for you is something I'm struggling to get around my head. I'm not sure if I'm even asking it correctly. Does time have any relationship with temperature of a system as observed by an outsider? I think of the temperature as a kind of kinetic energy measure of the particles of the system. Shouldn't they experience some kind of time dilation relative to the observer if their kinetic energy just kept increasing? And on the other hand, I've wondered if the inevitability of time is short of a reason why we can't cool a system down to absolute zero. Very good questions, Billy. These are really phenomenal, and I'm so glad you asked them. So yes, I heard a joke, I forgot where, but a thermometer is basically a speedometer for molecules. That's kind of one way you could think about it. A speedometer measures velocities. There we go. And we turn on the temperature. And the speed of molecules is how we perceive heat. So heat and temperature obviously are related, although you can have something with very high temperature, which means that you have a couple of molecules moving extremely fast, even close to the speed of light, as I'll get to in a second. And that would have a very high temperature, but very low heat. It wouldn't be able to do any useful work because it's just a couple of electrons. So they're related, they're not exactly the same. Now, as far as observer-dependent effects, I think you might be talking about temperature in relativity, in special relativity, not general relativity. But in relativity, when an object's moving close to the speed of light, strange things happen. Links contract, time dilates, and that's all relative to another observer. Now, for an object at a given temperature, you can distinguish between absolute motion and stationarity. So in general, let me take a step back. If you're on a train and there's another train next to you, we've all had that sensation, or a car, and it feels like either you're moving or another car is moving when you're moving or the other car is moving. You may indeed be stationary or vice versa. And that's because relative motion is impossible to distinguish in a physical system with any so-called tests using so-called inertial reference frames. But what comes into the Lorentz factor, which quantifies Lorentz contraction and time dilation, is not the velocity, but the velocity squared. And that's really important because kinetic energy, which is obviously related to heat, is also proportional to velocity squared. So in some sense, you could think of the Lorentz factor as kind of breaking down and having a term that does depend on temperature. And if you also had, say, a temperature, a black body, just a heated ball, a star or something, and it's moving at great velocity, that temperature is not affected intrinsically by motion at constant speed. Nor would it really do any useful work more than it could already do given its temperature if it were in accelerated motion, which is acceleration is distinguishable, unlike velocity, in a absolute sense. So three observers, if one of them's accelerating, they will, in general, agree. Two of the three observers will agree on which one is accelerating. But if they're all moving at some constant velocity, they will not agree that any one of them is moving and the other ones are stationary. So there's a difference in characteristic between velocity, which is a constant, which is an inertial frame condition, and acceleration, which is not an inertial frame. And so these things are very intimately related. Now, the question about absolute zero is incredibly important because at absolute zero, there's no motion of these molecules. And so there's no heat, even with an infinite number moving at zero velocity, there's no useful heat that can be extracted. So there's a deep interconnectedness between different physical concepts like temperature and time, which you asked about as well. We do believe that entropy increases with time, but what does that mean if you're just determining time based on what we perceive as the change of a clock? I sometimes call clocks entrometers or entrompeters, where it's sort of an entropy measuring device. Some say time is what clocks measure. We've had on conversations recently with Professor Chad Orzel, Union College, who's an expert in this. We had a conversation with his advisor, William Phillips, who won the Nobel Prize for measuring, very low, extremely small time differences using atomic optical lattices and all sorts of cool things. So these are very important questions that physicists are trying to reconcile, because to have an absolute definition of time that everybody agrees upon is not possible, and yet we do believe that temperature is a variable that people can distinguish, even if there is relative motion between the observer and the object in motion, so to speak. And then finally, there's a quantum mechanical version of time, in that we kind of overlooked this. The Schrodinger equation evolves as a unitary operation in time, it's smooth operation until you make a measurement. Then it collapses in a non-unitary, non-reversible form. Heisenberg's uncertainty relationship suggests a relationship not only between position and momentum, but between energy and time, suggesting that there's a fundamental energy quantum that is associated no matter how precisely or imprecisely you measure a time difference, or how uncertain you are in when something occurs. So if you combine this with the notion of thermodynamics, you could start to build a quantum sort of substitute for what time is all about. So that's a fascinating question. I thank you very much. You did phrase it perfectly acceptably. North Star 7694 and George Dubinin, they both say, great channel, great guests. I'm so glad to be on board. Please continue, sir. George says, I'm glad to be on board this ride. Well, keep going, get strapped in, because we're going even deeper into the impossible. My goal, again, is to turn the impossible into the inevitable, and you guys are along for the ride. All right, keep calm, ask kind of a pointed question. And he or she says, what is the story of you losing the Nobel Prize? Was that research that you were nominated for, or is it something you talk about with regard to the great scientists of yore or of contemporary times who could have won but didn't win the Nobel Prize? If only you feel comfortable sharing. I always love talking about my books. Here's one of them right here. So here's losing the Nobel Prize. Now this cover, by the way, you cannot get this cover because the photographer who took this picture was radically opposed to my politics, and he actually decided that I should not use his cover art, even though we thought we bought it from his photography dealership. We did not get the permission, and so Norton had to reprint this cover, and it has a different cover that you can now get, but that original first edition, those are collector's items. I once bought a used version of I ran out of copies I had gotten from the publisher, and I decided I would go on Amazon and buy a used copy because they had actually run out of the new copies. And there was a copy, it said great condition, collector's edition. And I was like, what the hell is this? That'll be cool. So I bought it. It was in good condition, opened it up and turned a couple pages, and it said there was an autograph from me. And there's a dedication to some friend or person I met. Dear Lisa, I'm so glad we're friends. And she sold it back to Amazon. So Lisa, don't think I never found out about that if you're out there. Okay, so what the hell does this book have to do with me and the Nobel Prize? So the story is how I created an experiment called BICEP, which later became enhanced. We enhanced it like an iPhone going to iPhone, 15 Pro Max. From what it started off as, the exact same telescope, optics, location at the South Pole. And that generation of experiment, 10 years ago, 2014, we announced that we discovered the spark, the inflationary gravitational wave background that produced B-mode polarization. This is before the Nobel Prize for LIGO, which would come 3 years later. And at that time, everything that seemingly suggested that we were right for a relatively long amount of time, maybe a couple of months, until it was retracted But everything up to that point, every newspaper, CNN, all sorts of outlets and scientists around the world were saying that people who were in this experiment should win the Nobel Prize. After all, the discovery of the CMB won a Nobel Prize. The discovery of the anisotropy, the fluctuations in the CMB won a Nobel Prize. And then later on, the discovery of gravitational waves would win a Nobel Prize. So it was a shoo-in to win a Nobel Prize. And in fact, somebody would have won the Nobel Prize had we been confirmed. But spoiler alert, the book is called Losing the Nobel Prize. So it's kind of a play on words. Because it means that I lost the Nobel Prize, but it also means, and none of us won the Nobel Prize. And that title came to me the night before the press conference, which I was not invited to, despite having conceived of the experiment. I was shut out of that press conference by a colleague and sort of former friend of mine, John Kovac, who I had hired as a postdoc when I was a postdoc at Caltech and moved to San Diego. And after the unfortunate suicide of my advisor and his advisor, Andrew Lang, John took over, and unfortunately, we don't have a good relationship anymore because it was essentially pushed out of this collaboration that I had founded, named, gotten the funding for, and by the time they were releasing the credit and trying to and make the announcement in front of the whole world, the New York Times, at Harvard, where he became a professor, I was not invited to that. So it was clear that, they didn't want me to be perceived in that way, and only 3 people can win a Nobel Prize, and so forth. He went on to win, Time Magazine's, the most fascinating people that year, all sorts of good things for him. And then, of course, it was retracted effectively, not the results still stand up, but the claim that we detected inflationary gravitational waves was retracted, in that we claim that we could only see dust, effectively microscopic meteorites, little tiny pieces of little needles that get magnetized. And these are the shards and shrapnel of a supernova that exploded 4+ billion years ago in our local neighborhood of the galaxy. And inside the galaxy, we look out to see the cosmos. We see particles of dust that we have to remove their contamination. If not, we will mistake that signal for the cosmic background, which is far more interesting. That tells us about inflation, whereas, studying micrometeorites and how they align themselves with the Milky Way's magnetic field is interesting, but it's not worthy of a Nobel Prize. So that's where it is. I also was asked to nominate the winners of the Nobel Prize the year after I could have theoretically won it. And a lot of, kind of painful associations happened during that time, because not only did nobody win the Nobel Prize, but now I'm asked to nominate a better scientist than me. And then later on that year, or a year and a half later, Barry Barish, my good friend and co-author of the foreword to my second book, Into the Impossible. Barry's the co-author of this foreword to this book, along with James Altucher, my good friend and podcast muse. So these are all incredible, kind of serendipitous occurrences. It's impossible to predict that this would lead to so many different things for me as a person, and indirectly leading to this podcast and leading to, you being one of 250,000 plus people that are, so gracious and spend your time with me. And then he adds at the end, or she adds, you're still an active scientist and nothing is impossible. So maybe yes, maybe I'll win. In fact, I suggest very strongly that the Nobel Committee offer me the Nobel Prize, if only to be a hypocrisy detector. Because if I accept it after the criticisms I give in the book, to the very much, consternation of many people, including the Secretary General of the Nobel Committee, who took issue with my book. Of course, I would expect nothing less. They're kind of a monopoly. They want to maintain that monopoly. And the job of monopoly is to keep as few people in the club as possible. So I expected him to do that. But, if they want to see if I'm a hypocrite after the criticisms I level against the Nobel Prize in this book, they should offer me the Nobel Prize and then see if I accept it. Okay. Thanks very much. Victor asked, congratulations, Doc. I'm happy for you. I believe you deserve this much more for the wonderful work you're doing, both in practical science and for divulging the most interesting stuff along the brighter minds. Love infinity. Victor, I love you too. That's incredible. I do try to do this. I don't get paid for it. I make a tiny bit of money from YouTube revenue, which it doesn't even cover the cost of my editor, my crack amazing team, Ryan Helms, Aileen, and just so many amazing people that work on this project. I have to pay them. And believe me, the money I get covers less than about half of it. So I do it out of a labor of love. I do believe that scientists that don't give back to the public in some way are, at some level a grifter. You have to give back. You can't just take and study science for its own cost. And this dirty little secret or dirty, pretty little secret, pretty little lie is that scientists are doing this all for the benefit of the public. No. We do it for free, most of us. I'm a public university professor. I don't get paid as much as those blokes at Harvard and Cornell and other places I get to talk to. Even, private colleges, I'm a state professor. So I do it for the love of science that people gave to me. It's my way of paying forward. Carl Sagan wrote books, and I would have loved to have him on. Isaac Asimov wrote books. I would have loved to have him on. During the pandemic, the world shut down. No book tours were announced, and I kind of saw that as my unfair advantage to take advantage of, that I would get access to these brilliant minds like, the Sean Carrolls and Freeman Dysons and people that couldn't travel to go and give a book tour. I got to talk to them. And along the way, I've talked to 19 Nobel Prizes, soon will be 20, and prize winners, and turned those into books. I met other co-authors like Carlo Rovelli. And we recorded an audiobook of Galileo, my third book. So it's led to so many serendipitous things. And that's why I think, even for selfish reasons, scientists should do things like this and give back. Even if you think I'm not good at talking. Well, okay, so you're born good at doing quantum field theory? That's total nonsense. You have to work hard at things, and you only work hard at things that you believe have value. And you might not think that talking to the public has value. And I think that that's a moral failing, because I think scientists really do what we do only at the pleasure of the public. So I'm glad that I serve you, Victor, and many other people. And I'm going to keep going. And there's no stopping. David Asher asks, Dr. Keating, amid the pursuit of understanding complex phenomena like dark energy and dark matter in physics, there's a prevalent approach of dissecting these mysteries into smaller components for analysis. However, considering the profound implications of these phenomena on the broader cosmic scale, why do we prioritize studying the minutiae rather than approaching these questions from a holistic macroscopic perspective? Is there an inherent value in dissecting the intricacies of the microscopic realm to unlock insights into the workings of the universe? Or should we also consider reversing this paradigm by broadening to the cosmic context to illuminate the nature of these fundamental forces? Wow, this is a freaking awesome question, David Asher. You guys are just so smart. I'm going to try to keep this clean. So why do we study microscopic? Well, there's a variety of different reasons that we do this. It turns out that the most microscopic things can affect the behavior of the most macroscopic things. So, one such obvious example is that you're made of matter, and matter is made of subatomic particles. I believe it was Victor Weisskopf. No, it was Philip Morrison who said more is different. So if you have an atom and you study an atom, a proton and an electron, they'll behave in a certain way. But then when you have 10 to the 23rd of them together, they don't just behave 10 to the 23rd times stronger. They actually behave like a gas rather than just an isolated atom. And that's fascinating, because the complexity of putting these things together does exhibit new phenomena that you couldn't understand if you just tried to start from the macroscopic. By just studying hydrogen gas by itself, you never learn that there's actually a proton in there and an electron in there and what are their forces and fields. And when we look at things like dark matter and dark energy, we have to say that there's very little we can do on the scale of dark energy. It's so weak. Dark energy is sort of like 100 orders of magnitude weaker than gravity in a way of thinking about it. It is related to gravity because it acts as if it has this negative pressure characteristic. When we include it in our equations for the expansion of the universe, it kind of looks like you add energy, and that energy has this pressure that instead of resisting being compressed, it kind of acts the opposite way and causes the expansion to expand, if you like, the expansion to accelerate. And so we don't know much about dark energy on a microscopic scale, but we only know about it on a macroscopic scale. Macroscopic being the behavior of entire galaxies and clusters of galaxies and things called baryon acoustic oscillations and the CMB. These are enormous structures comparable to the size of the universe at the time at which we observe them. So for that reason, we can only study, because dark energy is so weak, we can only study it by studying massive agglomerations of it and not on a microscopic scale. Dark matter, on the other hand, we know less about dark energy than dark matter, but at least we know that dark matter exists, and that may come as a shock to you. And we've detected dark matter particles. They're called neutrinos, and there's something like 1 trillion going through you every second, every day and night, because they come from our sun. and from other places in the universe, but mostly from our sun locally. Although there are right now 400 or so, about 150 neutrinos passing through you from the Big Bang itself every cubic centimeter of your body. So that's another, tens of thousands of neutrinos every second, traveling close to the speed of light, maybe even more than that. So this is all to say that we know that dark matter exists in at least one form called a neutrino, but that neutrino can't make up, or all the three neutrinos put together, they can't make up the preponderance of the dark matter that we see. We need something like, thousands of times more dark matter. We have made certain measurements of particles called axions, which again, we're studying them at a microscopic scale in combination with the macroscopic observations that dark matter does cause the rotation of galaxies to speed up as you go farther out from the central core, which shouldn't exist if all the matter is concentrated in the luminous stars themselves. So we first detected that was Zwicky and Vera Rubin and others detected the presence of dark matter in distant galaxies and clusters of galaxies. That was on a macroscopic scale. You're talking megaparsecs, millions of parsecs, millions of light years across. So that is something we only first detected gravitationally in the cosmos, and you can only detect it when you weigh enough of the substance to get an appreciable scale. And so we've been able to do that on the macroscopic scale, and we've even been able to detect a microscopic example of dark matter, the neutrino. But so far, this detection of another candidate that could make up the difference between what neutrinos make up and what so-called baryonic matter, chunks of rock, like these meteorites you can get on my website, briankeating.com. These things are not well understood just yet. There are candidates, and there are even hints from some experiments, and we're doing our part with the Simons Array and Simons Observatory and Polar Bear and many other experiments too, to try to limit or constrain the properties of so-called axions. And in fact, we've done that on multiple occasions already, but that doesn't mean that these axions actually exist. Okay, Sam Cena, John's brother. John Cena follows me on Twitter, X, formerly X. He's got 20 million followers, and I'm one of them. He's one of mine. I don't follow him back because I've tried to reach out to him, and I think it must be a bot. But it's a real John Cena, honest to good John Cena follows me. So if you know him, Sam, talk to your brother and get him on the show, because he is a relatively interesting philosopher, for such an Adonis-like figure. How do we know that the CMB occurred 380,000 years after the Big Bang? Oh, first he said, it looks like your channel has its own dark energy, accelerating the growth of your channel rapidly. Thank you, Sam. He also adds, I'm a rock star. Thank you so much. How do we know that happened? How do we measure the temperature differences between cold and hot areas to that precision? Again, you guys are so incredibly brilliant. These are phenomenal questions. So we know that the CMB, which is the cosmic microwave background, which is the form of science and astronomy and cosmology that I specialize in, that it comes from an epoch when the universe was about 380,000 years after the Big Bang. We know that because it results from the formation of atoms for the first time. And those atoms are atoms of hydrogen. Before that, we had a universe filled with protons and electrons in two separate positive and negative plasmas. And a plasma is opaque to electromagnetic radiation like light. So up until the point of condensation or fusion into atoms, only at that point could we see light, that light could travel vast distances instead of scattering every couple of meters off of either proton or an electron. And so when the universe cooled from extremely high temperatures a few seconds after the Big Bang, over 380,000 years later, it cooled down to about 3,000 Kelvin for millions of degrees. And now it's about 3 Kelvin, so it's cooled by an extra factor of 1,000. So we measure the temperature difference between the temperature today and that temperature then. We equate that to a time. And that's because we can calculate exactly for a black body, which is what the CMB is, the most perfect exemplar of a black body. It's characterized by one and only one number, its temperature. And so when a black body has a temperature greater than 3,000 Kelvin, it will ionize and keep dissociated those hydrogen atoms. Only once it got below 3,000 Kelvin do we measure its temperature to this day, at that time, to be 3,000 Kelvin. That corresponds to the ionization energy for a black body like the CMB. And that we know means, in combination with the fact that we measure the temperature today to be 1,000, that the universe, to be 2.7 Kelvin, that the universe has expanded by a factor of 1,100 times since 380,000 years, and the time that we measure today, which is roughly 13.8 billion years later. So then we can connect the expansion, the so-called scale factor. We can convert that to a time, and we can go backwards from today, when knowing the age of the universe today, and count back to when that temperature time product was equal to 3,000 Kelvin, and that's how we get it. And then how do we measure the temperature differences between hot and cold areas to that precision? So here's my beach ball, the CMB beach ball, named after my grand advisor, David Wilkinson microscopic anisotropy probe, or WMAP. But Sam's speaking about are these fluctuations. So how do we know this temperature is hotter than this temperature, which is blue here, and this one's red? The galaxy is this band around here. This is the Milky Way galaxy, which emits in all wavelengths, but in particular at these microwave wavelengths. This is what caused us to lose the Nobel Prize, because we thought we were measuring this clean region up here, and actually there's some trailing edge of emission from our galaxy that even invaded the part of the sky that we could see from the South Pole over here, say, and that caused us to be deceived to see this B-mode polarization signal, which would have indicated the inflationary gravitational wave background was actually caused by dust in our galaxy. Interesting, but not cosmological. So the way that these measurements are made in my telescopes, WMAP, is that essentially you have two different antennas, if you like, pointing in two different directions. And then one measures the temperature here, and the other one measures the temperature there, so two different spots. And then you go around the entire sky, and all you're doing is taking the difference between any 2 points on the sky instantaneously, and you just make this measurement over years. You orbit the satellite, it does its orbital dynamics, it measures the whole sky. And so it gets a difference between the average temperature and the temperature at this point instantaneously. And then we know the average temperature, that part subtracts out because every single point has either the average plus or minus some amount. So eventually you get millions, literally millions of measurements of this entire globe across the entire sky. And then you can reconstruct from where the spacecraft was pointing what the average temperature is compared to the temperature at a given location. And that's how I measure the temperature. And then the temperature of the galaxy is much hotter, and you do that as a function of frequency, and it gives you the behavior that a black body should have in each and every one of those regions. And these fluctuations, they look really bright, and the galaxy is very bright, but very bright being maybe 30, 40 Kelvin. The CMB is about 2.7 Kelvin. And so the cold spots are only about, 1/10,000th of a degree colder, if you like, in Kelvin than the hot spots are hot. So these are tiny, minuscule fluctuations at the level, of a few parts in 10,000 around a 2 Kelvin background, 3 Kelvin background. So these are fantastically small, and yet we do it every day with all of our instruments. My thumb's rather occupied right now holding up good old Carl Sagan, but yours is free to push that like button. And don't forget to subscribe. It really helps us with the algorithm. Now back to the episode. Okay, Bernard Wandel says, congrats, kind sir. It looks like your efforts are being acknowledged. Thank you very much. Okay, Blazin' Trades says, what do you see as the greatest challenge of our current educational system? And what can we do to see improvements in the future? Wow, where do I start? If you had asked me this question, here we are in May of 2024. If you asked me in May of 2023 or September of 2023, I would say the greatest challenge in the education system is getting more access to STEM subjects, science, technology, engineering, and math, and getting more students into the pipeline, and because our prosperity and our, kind of future as a civilization depends on, science and technology, I would have said. And now I see we have a moral rot at the center of our current educational system. It is just astounding to me. If you had told me, on October 6th that, a country gets attacked, say Algeria gets attacked by Morocco, and 1,000, or the equivalent of, 35,000 Americans say America is attacked by Mexico. Here I am in San Diego. And the Mexican, rebels and, cartel members, they storm across the border. They go to San Diego, they go to UCSD, and they kill every single student, every single professor, every single doctor, and so 35, 45, 50,000 people are killed, and then they take hostage something like 3,000 or 4,000 of the members of San Diego State, and they bring them down to Mexico and sequester them. If you told me that, and then within a day that there'd be protests on this campus by students for justice in Mexico, and they would say that the United States, that colonizers are not civilians, that people that that practice apartheid should expect it, and that the people who were killed in this attack on from the Mexican side, that they were martyrs, and we should give glory to the martyrs. All these things happened. Just replace America with Israel, Mexico with Gaza and Hamas, and civilians in Palestine. And people think it's only just Hamas, like that's all there was. There was a tremendous number of civilians that were killed, not wearing uniforms, not affiliated with Hamas, that did this. And so the moral rot is the worst part of the educational system. And I don't know. Right now, again, it's May. We have this tradition here. We call the Israel Apartheid Week, the Students for Justice in Palestine, along with 60 or so other campus organizations. We just had this past week on Monday, campus was shut down because there was an illegal encampment where there were knives and swords found and propane and all sorts of stuff, which the campus administration asked them a week earlier to remove peacefully. They let them demonstrate for over a week, and then they wouldn't leave, and they resisted arrest, and they were forcibly arrested, about 40 students or so, and 25 outside agitators. And even today, last night, the student government voted to not only divest from Israel, which they've already done, but also to prevent any scholars from coming from Israel and any students from going on an exchange program to Israel. We have a program with the Technion, which was in part founded by Irwin Jacobs, who started Qualcomm, and is a tremendous, was also a professor here. And they've now, declared that because of the actions that were taken, that we need to not only boycott scholars coming into campus, but cut off all support. Forget about doing research with Israeli companies or the military in Israel, which is an ally of the United States. Despite the fact that we have 5 Americans that are just Americans that are kept hostage, possibly dead by Hamas in Gaza, and they refuse to release them or their bodies in 8 months or so, that this demonization of Israel and of Jews and calls for intifada. Yesterday there was a huge, almost like a riot, a rally on campus where students and outside people, always with megaphones, wearing keffiyehs, covering their faces, screaming for intifada revolution. And that's equivalent to calling for another, series of terror bombing campaigns that took place in Israel in the first and second intifadas. The other thing is that they say, that this is the solution, is to have intifada, but they don't say that the solution is to have peace, to have a country of our own, which I had thought. I was in Israel on September 7th for my birthday, my bar mitzvah. And I saw zero reason why there couldn't be a peace deal between the Palestinians and Israelis. Israel was busy, dealing with Netanyahu and trying to get every single night. There were protests and riots against Netanyahu. And yeah, people say, he encouraged Hamas. That's all BS. He dealt with Hamas as an alternative to dealing with the Palestinian Authority. But in any case, I thought, well, this is great. There's finally a chance. They're unified. They don't like Netanyahu, so there could be peace. There's zero chance for peace. There's zero chance for a 2-state solution. And so when people call for intifada revolution, they're not calling for, we just want our own state. They're calling for perpetual war. And this has, really been highlighted by all the past developments and the moral rot. It's so deep on campus, and Jews are the canary in the coal mine. And it's always been in that way. And it's just for an educational institution where there should be scholars, not only working to bring in other scholars to see other perspectives. If I went on campus and started to say, I think that, Algerians are great. I'm not anti-Algerian, but the state of Algeria should be eradicated. And everyone who supports it is a Algerianist, and I am anti-Algerianist, and they should be destroyed. You'd think I'm a lunatic for good reason. So yes, you can criticize the government of Israel. Many Jews do that, but 95% of Jews are Zionistic. They believe that for the 56 Muslim states, there's room for a tiny Jewish state where Jews have right to sovereignty over their own lives and practice their own religion. You may not agree with that religion or practice that religion. I'm not the best at practicing it. But to say that any country doesn't deserve to exist and then say, oh, I'm not against the people that make up that country is sheer lunacy. So the only thing I can see for improvement is to ban hateful calls for, just as we don't allow people to say, whites or Jews will not replace us or Asians will not replace us, or death to the gays or something like that. That's repugnant. We'd never allow that on campus. But to say that it's okay to say Intifada revolution, there's only one solution, like the final solution of the Nazi Third Reich, it's sickening. And I don't think there's much we can do until that's eradicated on our campus. A couple of palate cleansers. Psychonaut 710 says, great job, Brian. I always watch your episodes. Thanks a lot, guys. And if you want to do something nice for the channel, leave a comment, share. There's a little share arrow on every video. Blast that out to yourself even. That really helps the channel grow. TCL says, keep on keeping on. I will, my brother. Bill Norris says, great job, friend. 500K is just around the corner, down the block a little bit. Well, I don't know, it's going to be a long block, but 300K could happen this year, and I hope it does. So the next one comes from Noah Reynolds. Given your discussion with both of these academics, I think he means Sam Harris and Robert Sapolsky, he also throws in Sabina Hassenfelder, why are you not convinced for their case for determinism? Love your show. Thank you so much, Noah. Okay, so Sabina, many-time guest on the podcast, she always uses sort of quantum mechanics as a way of, dismissing that determinism is sort of mandated. She typically says in her theory it's called superdeterminism, that quantum mechanics doesn't imply indeterminism. And she actually thinks that the probabilistic nature of quantum mechanics could imply just reflect our incomplete knowledge of it rather than intrinsically unknowable things. So her theory of superdeterminism, there's correlations between particles and states that are not coincidental, but they're determined by past conditions. And this is somewhat reminiscent, as she noted in her response to me, my episode with Sam, that she finds this very very appealing and not at all controversial, because states that we have now are determined by prior states, and that in her model of superdeterminism, things like Bell's inequality violations can be really decoupled or solved. You can solve the problem of these violations by assuming that things are determined from the outset. Now, how that is instantiated, how that's built in, is kind of not really clear to me. And if it scales beyond individual particles to collectives of particles, such as a neuron or an entire brain. With Sapolsky, I'm a pragmatist. I look at like his actions, and as he said in his talk with me, he's ashamed of the fact that he doesn't believe that there any such thing as acting as if you don't have free will. In other words, people act like they have free will. And, he maintains that he believes it's an illusion, and he does a decent job in his book, kind of coming up with all these reasons why, chaos theory and quantum mechanics and so forth. But he's not an expert in physical systems and the like, whereas Sabina is, but she's not an expert in, kind of collective dynamics of, condensed matter systems like our brains in a quantum state. I maintain that no sane human being behaves as if they have no free will. In other words, Sabina behaves in every way indistinguishable from somebody who believes they have free will, say the most religious person who believes that God gave us free will. And so I think it's interesting, but I think it's almost simplistic. Same with Sam again. I think that they're not as controversial as you might think. I mean, people think that they're robbing us of something when they say that everything is determined. But I don't see it that way. I see it just like cause and effect, that your current state is the result of a prior state. And call your brain, I'm thinking something right now. I'm not thinking about those words that are actually coming out of my mouth, but they're coming out somehow I seem to have no control over it, but I have a general architecture, a pathway in my mind. I'm not talking about like the Oliver North trial, and then I'm talking about, the ping pong championships in the 1972 Olympics. And no, there's a rough kind of architecture of ideas that I have in my mind. My brain is manipulating, and calling to the forefront different facts. Do I have control over that? That I can make you think of a miniature gummy bear elephant that's underneath your tongue right now, giving you edible cannabis type effects, and just enjoying this conversation? No, I can't say that doesn't mean that you don't have free will. Just because something is determined, like I'm determined that I'm going to be bored out of my ass because I'm going to a faculty senate meeting soon. I know that that's determined. There's no such thing as interesting faculty senate, but it's sort of my duty and I'm going to go to it. And in that sense, I feel like it's trivial. I also think it's trivial to say that a prior state determines a future state. And so I don't know how much there is to really debate about, which is why, I kind of didn't see the kind of hostility to the reactions that people have from either my interview with Harris or with Sapolsky. But stay tuned for questions about that now later on. Carlos Davalio says, I want a video where you discuss the Mond theory in detail. Well, you're in luck. Not only do I discuss the Mond theory in detail with two scientists, one of them is the person who came up with the Mond theory, Mordecai Milgram from Weizmann Institute. We had a conversation. I need to do a part 2. The audio was not great on that episode. Let me see if I can find out what that episode number is. We started numbering the episodes. That took a lot of time, cost a lot of money to go back. I wish I had done that in the beginning. Numbered my episodes, but let's see if I can find that here. What is that episode? No, it doesn't have it, but the title is No Dark Matter on Mond with Mordecai Milgram. You can find that title, and the thumbnail says Dark Matter doesn't exist. That was 2 years ago. Audio sucked. I'm sorry for that, but I will do another one with him. I also did a Mond video with Stacy McGaw, my alma mater, and Stacy was kind enough at Case Western to do an interview with me, and it's called Better Than Dark Matter. Stacy McGaw. That episode is number 284. So that, at least I have it. It's a deep dive into that. So enjoy that. And I've even talked about Mond with Sabina Hassenfelder on a variety of different episodes. So you're in luck. The speed of C, negative comment. Uh-oh, this is bad. It's entirely obvious that you love science and educating the masses about science. Yeah, I do. Thanks a lot. But let's be honest, Brian, you do this just for the green ink on paper too. Many of your videos I've watched have copious amounts of channel hyping to the point of being slightly off-putting. Off-putting. I'm stopping eating pudding. Just some feedback, no hate. All right, speed of C, speed of light. Here we go. The green ink on paper comes in at about, I think it's a penny per view. So if I get, 100,000 views on an hour and a half long video, like I did with Brian Greene, where I flew to New York City, interviewed him, stayed in hotels, went to his place, took Uber, cost me $600 to do that. I might make $1,000, total. And that doesn't count. I had to edit the video, pay the editors. We had to put it out there, host it, and all the work that goes on behind the scenes. And how often does that occur? Almost never. I mean, very few videos, with 3-hour-long conversations with string theorists make enough sense for people to watch it. To pay back the amount of money that it costs to make it. So I make very little green paper. I make little copper pennies per view, or fractions of a copper penny on some videos, 0.7 cents per view at most. Now, channel hyping. So why do I do the request, as I'll do right now? Join my channel, subscribe, because most of the viewers that watch don't subscribe, even though they come back again and again and watch it again and again. They don't like me or dislike me necessarily. Rather, they might not like me either. But here you are. But it's like 50%. It's incredible how few people subscribe compared to how many view it. So, some of my videos have 1 million views, and I mean, I love every single subscriber, but I have fewer than a quarter of that number of actual subscribers. And also on audio is even lower. It's, something like 60, 70,000 downloads, and daily active listeners. On podcast feeds, Spotify and iTunes being, some of them Snipped, my favorite new podcast player. Check that out. No affiliation, but I just like what they do. So I appreciate it, but, it's like you have to preach to the choir. I do exactly 2 interruptions per episode. 1 to ask you to subscribe and leave a comment or rating. These are things that cost you nothing. Hit a subscribe button, hit the thumbs up button. These don't do anything. And they actually can make a leveraged increase. And so maybe I should make a deal. I will not ask as much if we get that number from 50% up to 60% subscribe. I'm never going to have 100% subscription rate. That's okay. And the other thing I ask for is you to subscribe to my mailing list, which briankeating.com/list or briankeating.com/edu. If you have a .edu email address, you're guaranteed to win one of these meteorites. It costs me money to send it out. Takes a lot of time. And I also prepare these newsletters. I write it every week, and it's a lot of fun to do it. And again, YouTube could take me off tomorrow. I mean, if I have on Brett Weinstein again, he's been demonetized, kicked off YouTube himself. I've had on Patrick Bet-David. I've had on Eric Weinstein, obviously, many times. I might hopefully get Peter Thiel on. That could be demonetized, taken off the air, and that wouldn't exist. I have no way of communicating, real platform. And I do this because YouTube is a great platform and does promotion and so forth for me. So that's a problem. But if I have a mailing list, I'm able to communicate with you and maybe send you to another platform. I've got my website. And so I'm able to get access directly to the audience and share things with you. I'm a human being. But to think I'm doing this for the green paper, for the money, people say, jackass lawyer says you do owe me money. Send me some money, rich man. Okay. If you think that a state university professor, is getting rich off of a YouTube channel, you're sadly mistaken. So I know it. People, the thing is, if you produce great content, people will naturally subscribe. Mr. Sidney says that. No, you're absolutely wrong. Even the biggest channels, if you look at, huge channels with millions of subscribers, and the one that, I look at a lot is Diary of a CEO. It's a great podcast, totally different. I love to consume Stephen Bartlett's content. He does the same thing. In fact, he's the one who gave me the idea to do it. He's got 5 million subscribers or something like that. He doesn't need more subscribers. He does it every time because it's something like in his channel, maybe even fewer people are actually compelled to subscribe. Now, does he not make good content? I think that's nonsense. I think I'm making some of the best content on YouTube for deep dives by and for and with other genius authors in the STEM field. I know it's never going to be as big as Rogan or something like that. I don't want to be as big as Rogan. I think there's a lot of detriment for that. So anyway, I don't do it for the money, but the only thing I do ask is people would subscribe. It does help grow the channel, get more attention, and we can get better and better guests. I often don't get guests on the show, and it's something that I don't really like to say, but to get a big guest, like I'm talking with Andrew Huberman. I just got a text from Andrew Huberman right now. I'm not like blowing my horn, but I'm going to get him on this podcast. It's probably and he's invited me on his. And that's wonderful. And I hope I will go on. I'd love to talk to him about night vision and how to be a better astronomer. He's an expert in the visual systems. What happens when the night sky goes away due to light pollution? This is unique content. You're not going to get that anywhere. But, he's not probably going to go on a channel that has only, 10,000 subscribers. It's just the way it is. I don't go on channels that have fewer than 1,000 subscribers or 2,000. Usually I say 10,000. I'll go on it. I just don't have that much time. I've got a big family. I've got huge responsibilities. I'm the PI of a $110 million project that I'm leading with 360 scientists from around the world. It's a lot. I'm teaching 60 undergraduates, 4 graduate students. I do this 1 day a week. I love doing it. It's an intellectual outlet and kind of a therapy session for me. I get to talk to these incredible people. I get incredible opportunities. I've done just the last year. But no, you're just totally wrong, Mr. Sidney. I challenge you, Sydney, Jackass Lawyer, The Speed of C, make a channel. Just make one video. Just do this for me. Make one video, dedicate $500, maybe $1,000 to it. Just you do it once, just see if it's an experiment. Make the best possible content you can, and then see how many people watch it. And then see how many of those subscribe to it. And then send me a comment in my next subscriber celebration, and tell me how it did. I'm totally honest. I would love to know if you know some way to do this, to get all the artwork, to get all the thumbnails, the titles, the AI kind of search engine optimization. It's an incredibly hard thing to do, which is why so few people actually can do it, which is why the number one job that most kids, millennials want to do nowadays, and Gen Z, is be a content creator on YouTube or TikTok. Because it's so rare that you can make a living on it. And I know I'm not going to make a living. I'm comfortable. It's a hobby. I used to have an old, a Cannondale bike, and it was a hobby. I'd ride it. I spent so much freaking money on that thing. And then I just ended up throwing it out when I had kids. So not everything has to be monetized, but just because I ask you to subscribe doesn't mean I'm doing it for the green paper. Whew. All right. Negative comment from Jim MN7YQ. I'm disgusted by the smear of Trump. He's talking about Sam Harris. For those who don't know, Sam Harris is a self-absorbed punk who tends to use phrases such as, "We all know Trump is Hitler and the most corrupt individual to ever walk the planet," to appeal to his cadre of TDS, Trump derangement syndrome victims. Then, instead of backing his rabbit claims up, he moves on to another smear after smear. No wonder Brian looks dumbfounded. Harris is an optimistic con man using carnival techniques. And then he goes and he puts up this clip. I'll show it. Watch the clip, 59 seconds. This is the one where Sam was on with my friends Konstantin Kisin on the Trigonometry, the podcast, which I've been lucky enough to be on. This is a clip from David Rubin where, Sam is basically saying, I don't care if Biden's sons has pictures of dead children, something like that on it. Anyway, I'm not going to go through the whole, he keeps going. Everything is blocked. So this is a good learning lesson for me. I don't think so. I think it's fun to talk to people. I did give it a special audio intro to Sam Harris episode, which I didn't put on the video just because it was meandering and long. I really enjoyed Sam. I enjoyed it more than I thought I would. I felt we had a great rapport going on, even though he did, for a long period of time and was talking about Trump, Elon Musk, Tucker Carlson. People say, oh, he only talked about Trump one time, but he also, very similar kind of language. And I'm not saying his language is unjustifiable, but this language of describing, people as, attention, seeking individuals that have no accomplishments, talking about Elon Musk and not that Elon Musk has no accomplishments. He's obviously one of the most accomplished people in history. Tucker Carlson is also extremely accomplished. But, I can't stand, I find some of the things that Tucker does abhorrent. One of the few people I probably wouldn't talk to on the podcast, but the point is, I think I was not caught unaware of what Sam's position on Trump was. I was surprised by kind of the depth of it, and he did indeed refer to him unfavorably compared to Hitler. And I didn't interrupt him. So for all of those, why did you say that to Sam on the audio intro? There are a lot of really tushy hurt people out there who felt I really hurt Sam. I owe him an apology. You listen to the episode and imagine like your spouse being compared to Hitler. Would you say, oh, that's just Sam's opinion and whatnot? And, you would probably want to push back, I would say. And it's not like Trump is my BFF. I think he's far superior to Joe Biden on a number of fronts. I think Biden's been an absolute disaster on many fronts, and the world is kind of burning all over the place, and multiple wars and zero peace agreements signed, and a complete lack of comity. And he was supposed to bring the country together and started off because of Charlottesville. It's just a bunch of lies. And I'm sad to say it. I was hopeful. I thought Biden could, maybe he could be the kindly old uncle, Uncle Joe that we need. And he's turned out to be a pretty vindictive, person that's made the world a lot less safe. And been responsible for the degradation of a lot of things, including the border, not so far away from me, where we had 100,000 illegal immigrants coming from across the border in the last few months. So it impacts directly, they wash up on shore, literally on the campus of UC San Diego. This is not like, I'm saying something that's not well known. So, So I'm not certainly a Biden supporter, but it doesn't mean I'm a Trump, fanboy. It's just that we have the lesser of two evils in some sense. Yeah, it's still evil. That's reality. I have friends that are trying to work on third-party candidates, maybe Bobby Kennedy, who knows. But the point is, we probably are going to vote for these same two, years again. And so I wasn't defending Trump, and a lot of people felt that, I was too sensitive. But just again, imagine your wife, your professor, your uncle, even if you don't like him that much, was compared to Hitler. And worse than Hitler. Watch the interview and tell me what you think. Okay, next one. We have an interview from a question from Justin Watkins. Is it time to stop taking Sam Harris seriously? No, I don't think so. I think Sam's an interesting scholar. I talked a lot about science and MRI studies and all sorts of things. I think he's kind of had a different frame of mind, seeing the censorship and so forth. I think he's got some good perspectives on things like social media. I'm a paying subscriber to his Making Sense app. Not his Making Sense app, his Waking Up app. He has another thing, which is podcasts. He's great at doing the monetization. And I think he's a serious intellectual. He has a moral clarity on a lot of issues. I think he does have blind spots, as we all do. And if you can find someone that you agree with 100% on everything, you might need a psychologist to talk to, because you might be inside of a rubber echo chamber room. Okay, Des Oxen says, can't you just acknowledge that you tried to gaslight me regarding an AMA that you didn't end up doing? I'm not mad or anything. I actually find it hilarious. It was just a funny thing to do. I understand you have a ton of real bleep to do in your life, etc. I can easily find it, but this was maybe 5. I don't remember what it was. I got literally, 250 questions. I'll probably get through 30 of them today. I love the questions. I do read every one of them. It doesn't mean I didn't, I only have so much time physically right now to read to read them and answer them in the detail. I think some of you guys are asking about thermodynamics and relativity. And then others of you are asking about TDS. So I love the audience. I love the diversity of people I get to talk to and the people that I have in this audience. It's phenomenal. So send it to me. Maybe it'll get in. I ask AMA questions all the time, even for people whose podcasts I've been on, like Chris Williamson. He doesn't answer them. I don't take it personally. He's a friend. So, yeah, don't take it personally. I didn't try to gaslight you. By Jamal says, differences between different universities and countries and their ability to attract and keep different scientists. What are the current missteps in our education chain that need to be addressed? Making sure we can keep up to date with all the new research between different disciplines. How long it takes for students to be productive researchers. Idea stealing, taking credit for others' work. Okay, there's a lot of stuff here, but let me try to parse what the question is asking. So what are the different missteps, and how do we attract and develop scientists? Well, one of the worst ways is to try to make them exactly in your image and to attract them to do exactly what you want them to do. Because the best graduate students and undergraduates even can surpass you, even the most brilliant scientists, and that you learn more from teaching and from your students than you yourself may know. So I think our current missteps right now is that we kind of have made a deal where the scientists like me and engineers and physicians pay the bills for the university so that we can have an ethnic studies department to teach that Israel and America are colonial states built on stolen land and so forth. I find their views abhorrent. I find them ridiculous moral imbeciles in most of these sociology, anthropology, and so forth, even though I have many friends in those departments. There's a great deal of rot in them, and the university would be better off without these people. But I support their ability to be here, and if not for academic freedom and tenure, they probably wouldn't have a job. We had some professors, get arrested at this protest. Now, if you're a student and you're 19 and a half years old and you want to protest Israel and America and talk about the Revolutionary Communist Party, it's your right to do it. And I support it. I think it's cool. I protested. I went to protest, during the Iraq War. I didn't think that was, this is the first Iraq War, was okay. The second Iraq War, maybe not so much. Whatever. We all do things. But for a professor, a senior tenured professor to get arrested and then not to teach or refuse to teach, as a way of protest, I don't care what it is. If I said, to my colleagues in ethnic studies, if I said, I want you to join this petition to protest on behalf of the hostages, and in particular the IDF. I really want you to, and I'm going to take off from teaching, and I'm not going to teach until the American hostages are released and the IDF soldiers are no longer being fired upon by Hamas. If let's say that was my position, I expect that the university might stop my paychecks from flowing, and that's because I'm a public servant. I signed up to do this. I cashed paychecks. And my students deserve to be educated. I had students ask me not to teach this past week in solidarity with the students. And I said, absolutely not. I'm going to keep on teaching. People pay to teach, pay me to teach, and I enjoy it. And I want to continue doing it for the benefit of these people that are just trying to get an education, not to be political activists. And all these people saying, they couldn't imagine not protesting, and there are human beings dying, and 35,000 civilians have been killed, which is Hamas's figure. We have no idea if that's true. They know to the person how many children were killed, but they have no idea how many hostages are alive. It's all nonsense. And none of these students were protesting Uyghur genocide or Sudan or Darfur. They weren't protesting any of these things. China's treatment of Tibet, China threatening Taiwan, Iran, even before October, they weren't protesting anything. So I think it's deceptive. It's a good time. It feels good to do it. It's okay to do it as if you're a student, not as you're a professor. So I think a lot of the professors have big challenges. I think the professors that participate in these things are really doing an immoral act to deprive the students paying for their education. Imagine if you signed up for Tony Robbins' course and you paid $14,000 for the course for the quarter, all in and everything, and then he just didn't show up because he's pissed off at Hamas. Let's just say, I don't know what his politics are. You would demand your money back. How are these students supposed to get their money back? Go on Zoom? So it's ridiculous. So a lot of these departments are worthless in a lot of ways. They don't educate, they indoctrinate. I think that's a bad thing. I think we should have way more resources dedicated to STEM fields. I think places like Caltech, MIT, they churn out incredible people, even in the non-sciences and the soft sciences rather. They do a great job, and there's no reason why most universities can't do this, especially when you look at their return on investment. What is a person with an ethnic studies degree going to do besides keep on getting jobs in academia, bureaucracy, DEI at different universities or institutions? It's not what a scholarship. What I think about when I think about scholarship at a university, demanding of and requiring things like tenure. Okay, how long does it take for productive researches? It's hard. It depends on the student. When you have a student from, who has a very good internal motivation, she or he can outrank and start writing original research and doing original work. It's harder as an experimentalist because it's impossible to get research at the high level that you do it in a graduate school as an undergraduate. No professor I'm not going to pay an undergraduate in most cases to go down to Chile, which cost me $8,000 minimum, with all in for 2 months of staying and travel there, and weeks of getting back and forth and then lodging and so forth. I'm not going to pay an undergraduate to do that, and then an undergraduate can't do that. And going for a day or two on spring break doesn't do me any good and costs the same amount of money almost. So it really only isn't until grad school that an experimental grad student in my lab can get the experience where he or she can actually contribute. And then so they're starting the clock learning. Not even in their first year because they have all these mandatory required classes or exams they have to take. So it's really not until the second year they learn how to do experimental research. And then they get really good at it, 3 or 4 years into their degree. And then they graduate 5 or 6 years into their degree. So, it's very difficult. So it does take a long time. Now, how do they behave and how do they prevent against idea stealing? I've talked about this with, Guido Inbens on the podcast, won the Nobel Prize in economics. 2021. We don't do a good job of ethics, teaching about science ethics, which involves, taking credit for others' work. It's really kind of up to the instructor, the professor, the advisor, the mentor. We don't have required classes in grad school, unlike the business school, the med school, the law school. They all do. And I think we could learn from them. But so far we haven't. Okay, Wolfenstein, recognize him many years back, original subscriber. What are the building blocks of space-time? Do they express physical constant? Are they related to wave functions? How do they behave? These questions are kind of the dominant questions in theoretical physics to this point. Some say, like my friend Eric Weinstein, I talked with him today, checking in on me. I haven't done a podcast in a long time, but we are getting together later this month in May. Stay tuned for that. We don't know, but this is the highest prestige aspect in all of science. Physics has the highest prestige overall in science, for better or for worse. Math is even more difficult and might even have more prestige, but then the most mathematical aspect of physics, which connects to evidence rather than just pure mathematical concepts, is theoretical physics. So that's why theoretical physicists like Feynman, Gell-Mann, Sheldon Glashow, all the people I've had on, Roger Penrose, these people have, I didn't have Feynman on, by the way, Einstein, these are theoretical physicists. And what they do is represents kind of the pinnacle of the human mind, because they do have to take into account the confrontation of empirical evidence, data, and so forth with their theoretical models. Or the best ones should. Many of them don't. And in fact, they'll continue doing it, most notably in the context of string theory, which posits that the fundamental building blocks of reality, Wolfenstein, as you know, are not zero-dimensional points like particles, but they're one-dimensional strings, and they vibrate in a higher extra-dimensional manifold. Space-time fabric could be 10, maybe 11 dimensions with space and time included. There are alternatives that have received the logarithm of the amount of attention. Spin networks, loop quantum gravity, Eric's geometric unity, which might only have him as the primary supporter in the academic environment. Then there's E8, like Garrett Lisi's theory. I'm told there are other approaches as well, but it's sort of a power law. String theory gets almost all the attention. And yet we haven't had one shred or one bit of evidence for it. I've tried to have on Ed Witten. He declined to come on. Maybe that's for the best. I disagree with his politics vehemently. If you want to avoid, kind of fighting with your guests about politics, it's always a good thing as a podcaster, I'm told. And so he won't come on. I tried to get Nima to come on. He said he would come on. He so far has ghosted me recently, so I don't know why, but maybe he'll come on, or I'll go see him in Princeton one of these days. And I've had Juan Maldacena on many, and I've also had on Kamran Vafa and many others. And it's been interesting. Stay tuned for episode with Robert Brandenberger, who's got an alternative to string theory. And these are all interesting. I'm always curious, what is the ground truth that we can connect to an observation? And I find those sometimes sadly lacking. So can we get physical constants? That's not clear if we can from any of these theories, but it would sort of be a great goal to have access to a measurement of the physical constants, the speed of light, if that could come from a more fundamental theory. Right now, we don't believe it can be. Okay, Alexander's 2757. I commented this before, the Charles Bueller drive that just got patented about 2 weeks ago. I have no idea what that is. His math is included in the patent. You can find it online, as well as an interview. I did not go to college for physics, so I don't have in-depth mathematics. But if there's something to an E&M drive, thank you so much. I'll look into it. I don't want to waste time right now to do that. I'm not familiar with it, but it's a propellantless propulsion drive, which would be kind of interesting to do that. How could it actually create something? I'm only seeing stuff on Reddit, which kind of always makes me nervous. So what exactly is it? Some people are calling it, debunked. Now, is it really patented? I'm not seeing any. There's something called patent pending. That's usually anybody can file a patent and then say it's patent pending. But when the patent is actually filed and applied, I have 2 patents. Never made a dime from them. Never got any attention from them. And so this is sort of kind of discussing this. NASA engineer Exodus propulsion technologies revealed that it appears to defy the known laws of physics. So I'd love to know what his physics background is. He only is claimed to have a connection to NASA, which has in principle nothing to do with fundamental physics and gravity. So I find it very speculative. I'd love to see the patent, and see if it's actually been issued. You said it was filed 2 weeks ago. Was that issued 2 weeks ago? We'll see. Maybe by next AMA we'll know more. Okay, Marcelo Temer asks, working with measurements that are too abstract for 99.9% of the people, how do you explain your work in cocktail parties? Oh, I'm very popular at cocktail parties. When I go there, sip my Chris Williamson New Tonic. If you can't make physics interesting to a layperson, then you are a lame person. We're given literally the greatest script ever written by nature, God, whatever you like. It's our job. You have to work to make it boring. I mean, we did everything from, discovered DNA was by physicists. The nuclear fusion, fission, weapons, searching for extraterrestrial technology, looking, for the leftover heat from the Big Bang, discovering the accelerating universe. If you're not, interesting to people, then you're going to the wrong cocktail parties. I love it. I'm always, my wife will always, hit me in the ribs and, shut up, stop talking. I tend to overshare, but I always find people are interested in it. And, again, I feel like you have to kind of work to make science, which is abstract, but to be able to explain it to a layperson, is completely possible. And I find it a great privilege. And that's why I not only say that it's a moral obligation for scientists to explain their work to people in a way they can understand it. That's sort of my tagline. But also it's good for scientists to do it because you develop a whole new set of capabilities which serve you outside of science. And some of those, ways that it's served are through the entrepreneurial spirit. Galileo was an entrepreneur. He had to sell the telescope. He had to rent out his apartments. He had to write books. And you have to get people to buy. And it's not enough, as I said earlier, to make great content. You have to advertise it. And advertising is selling and marketing. And it's not true that just having a good product makes all the difference. I mean, there was a guy who invented the telescope before Galileo. His name is Hans Lippershey. Galileo improved it and then made these measurements. So if it's all about just making the great content, it wasn't so much greater what Galileo made compared to Hans Lippershey. And yet nobody knows Hans Lippershey's name and everyone knows the name of Galileo. So think about that. You have to really work hard to not make physics interesting. Okay, J Mo App. Most important question, how are you, my friend? I'm doing great. I'm looking forward to great new discoveries in my field and my experiments with my colleagues, Simons Array, Simons Observatory, even Polar Bear, and this new stuff for my competitors on Bicep. It's the greatest time to be a scientist. Just this past quarter, teaching my cosmology students, 60 students, the most brilliant young students, I'm getting almost 100% attendance for the first time ever. And I think it's because of this YouTube channel. I'm trying to make it interesting. I'm forcing them to watch the YouTube channel and like and comment. No, I'm not doing that. I like it if you're watching out there, Physics 162 students. Tell them if I'm a good teacher or not. I'm doing my best. I'm bringing in experiments into a cosmology class, which is primarily theoretical. I'm doing explosions and teaching about electron beams and anti-gravity and all sorts of cool stuff. So I'm having a blast. Okay, DM 31415. That's an interesting number. Those are the middle digits of pi, I think. If energy and mass are quantized, so the forces of nature, depending on them, are finite, why scientists say that gravity force is an action and an infinite range of action? There wouldn't be a far distance beyond gravity attraction force to be zero. Great question. So I recently talked to Claudia de Ram. I think this episode will be out before the episode that I'm doing now, the 250K episode will be out. Maybe it won't be. Maybe we'll get this out fast. Claudia believes that gravity could be massive and that a force's range depends on the mass of the force-carrying particle. So in the strong and weak nuclear forces, we have bosons that do this, that mediate in the weak force, the W and Z, and we have gluons for quarks. And we have photons for electromagnetism. So the difference between a W and a Z boson is that they have very, very large masses, incredibly large masses compared to even a proton. And because of that, they interact very strongly, but over a very weak range. Strength of interaction and the distance over which that interaction can interact are inversely proportional. And that means that for a massive particle like a Higgs boson, which is like a giant heavy photon, it mediates it via these parameters, is that it's these objects are incredibly heavy. I mean, a W boson, looking up 80, yeah, 80 times more massive than a proton. So that's insane. So that means that the weak force is very short, which it is. It only interacts in the scale of nuclei. It's what keeps the nuclei, that's what causes or is responsible for radioactive decay. So now the Higgs, the gluons and so forth are much even stronger than this and weigh even more. And so let me get the mass of the gluon here because I don't have those memorized. The gluons are even shorter and they act over shorter range, but they're even more massive. And that's these are all manifestations of something called Yukawa properties. And so, yeah, it's incredibly interesting that the longer range of force is, the lighter its force mediating particle, namely its bosons in the case of the weak nuclear force, and the boson of electromagnetism is the photon, which is massless. And so that can go across the entire universe, which is why we can see the CMB and so forth like that. And so, so these are incredibly important topics. And people like Claudia do believe that maybe the graviton could have mass, meaning that it has a shorter range than the size of the observable universe, and that would have observable consequences that we could potentially measure. Okay, great. Life equals 42. Could the universe be an infinite multidimensional fractal? It is sort of a multidimensional fractal if you look at the structure in terms of the patterns of self-similarity and scale invariance, the galaxy clusters. If we can put in a picture of the cosmic web here. Even like the Hubble Deep Field, if you scan in an individual galaxy, you'll see these kinds of spiral patterns and so forth. But no, I don't think it is an infinite multidimensional fractal, but it could be. It's possible the universe is spatially infinite. We just don't know. We know it can't be smaller than about 93 billion light years in radius, the observable universe, which is incredible. And so, yeah, this is these are all interesting things to consider. But no, and it's typical, unless you're talking about like some precise aspect of physics, like I said, the structure of space time and stuff like that, or galaxy cluster, large scale structure, that there's a problem. You can't really say it's an infinite multidimensional fractal. That sounds a little bit too much like woo woo, and it would be best left to say no, but it is possible. Okay. Dr. Van Helsing Z 5133. It was clear from your episode with Sam Harris, that you engaged in the Trump discussion as much as he did. As a matter of fact, you're the one who brought it up the second time around. So again, people say, oh, you talked about it so much, but we talked about it in different realms. One was in the context of Trump saying Hitler as a cult of personality and a danger to America should he get his second term. That is Sam's highest priority. You have to admit that, Doctor. So then Doctor asks, why then disavow the conversation and label him as obsessed? Well, a few subscribers leaving is enough to make you cower. No, I lost a lot of subscribers by just having Sam on. So the fact that I put him on, and not only did that, but I aired the whole conversation, and like I said, we had a great rapport, and even been in touch after the episode. So I think that's a false assessment, that I was disavowing the conversation. Certainly not true. I would gladly talk to him again. If we talked for 3.5 hours, and it was really only towards the end we started to talk about slavery in the Old Testament, and it was clear Sam has no idea about the actual. You may disagree with me and think I'm stupid for believing in a 3,000-year-old book. It's pretty amazing that a 3,000-year-old book is still relevant to several billion people 3,000 years later. But leave that aside. That doesn't prove anything. But let's talk about it. It's not important that I was trying to convince and convert Sam to his Jewish heritage again. No, it was just to point out that his factual assessments were inaccurate, that he claimed certain things, were like slavery shouldn't appear in a holy book. And it was clear that he had no idea what the nature of so-called slavery was in the context of the Old Testament. Now, I'm not a rabbi. I'm not a Talmudic scholar, but I know a lot more about the laws of the Talmud than Sam does. So I think accuracy and precision are important. And I assume that Sam would find that as well. And I'm not sure if that conversation made him, that part of the conversation made him upset and not willing to maybe come back on again. I don't know. I don't really care if he does come back. I think we had there were a lot more questions I could have asked, but it was good to talk about that in the context of something he brought up again, that we could write a better Bible than God, just because we would leave out slavery. And then he has no factual connection to what slavery actually was in the Old Testament. He's absolutely right about it in later application of it. In fact, slavery is practiced to this very day. And his point was, well, the Bible, if it didn't give comfort and aid to slaves, the having slaves, even though they're what we call indentured servants, then we wouldn't have had slavery in the South. That's just BS, because we have slavery in the large parts of Africa and the Middle East to this day. And in the country of North Korea has about 30 million slaves or more. So do they practice Talmudic Judaism? I mean, I find that preposterous. So anyway, I'd love to talk to him about it. I've talked to other atheists, and he's the only, he and Dan Dennett, who's unfortunately now deceased since I did the interview with him. Sadly, the only horseman who's left is Richard Dawkins. I will try to get him on. My thumb is very busy right now holding up good old Albert, but if yours is free, please go ahead and hit that like button. And don't forget to subscribe. It really helps us with the algorithm. Robert Wright, 7937, says why and don't say because. I will say why not. Kay Hawkins, wow. Won't watch is that Harris dude is a propagandist. He spreads MSM, mainstream media, talking points as truth when he's so unenlightened that he's become a parody. Okay, so here's an example of one of my subscribers. Presumably he's very tied in because he answered, or she answered a question on my community page, which takes even more due diligence to look for. Thank you, Kay, for looking so deeply into my content. But she's saying this kind of ridiculous statement. And again, she's saying, I won't watch it because you had Sam on. Then other people are saying, why were you mean to Sam? So do you understand? I can't really win if I confront Sam about this perspective that he's has a particular animosity towards Trump, specifically towards Trump. It's not like he's a right-wing, he's calling their whole right-wing fascist. And so he's been exceptional when it comes to moral clarity on Israel and Hamas. He was exceptional when it came to Black Lives Matter and the kind of just ridiculous overbearing and damage and destruction to our society that occurred because of the George Floyd, death of George Floyd. He was great during that period of time, less great over COVID vaccine, but still great over COVID itself. So I have nothing but respect for Sam, where he's an expert or he takes great care to think thoughtfully about. I just think that in the realm of Trump versus Biden, that's all we have. That's all we have here, that he has a blind spot. And I think it can be disproven very, very easily from a Bayesian framework that Sam certainly understands, which is that Trump did not. And I can't remember if I mentioned this in the podcast with Sam, but Trump had his opportunity to be a dictator. And if you say, well, he thought he would get, January 6th was really the insurrection, blah, blah, blah. He still had 2 weeks after that. He could have abrogated the Constitution, right? He didn't do that. He didn't even pardon himself for some of the crimes that he was already accused of, like the Stormy Daniels affair that's going on now. So it's strange, it's like they consider Israel to be genocidal when the population of Palestine, the Gaza Strip, has quintupled in the last 50 years, 60 years. It's like the worst, and they're bringing food and notifying peaceful civilians in Gaza that they're going to blow up a building where terrorists are shooting rockets from a hospital, knowing that they can use civilians as human shields. If you say that's genocide, then that's probably the worst genocide ever, and that Israel needs, genocide lessons. And if you think that Trump is going to be a dictator and is going to be a despot, he sure didn't avail himself of it when he had the chance. He knew at a minimum he couldn't come back for 4 more years on January 6th. But yeah, again, I don't think he is a dictator. I don't think he's going to act like it. He makes jokes. He speaks off the top of off his lip, and that's how people came to find him a prominent figure back in 2016, you remember, by kind of disregarding what he said and listening to his words. And did he act as a dictator? No. Do we have any wars, major wars, as we do now, around the world with huge billions, hundreds of billions, a fraction of $1 trillion to these wars to support, America's allies? Although today I'm speaking, Biden's decided to not fund certain weapons, that just the precision guidance component of certain bomb armaments and artillery and stuff for IDF. That's disappointing because it'll mean more civilians are killed, sadly and tragically. And I think the blood, will be shared between Hamas and the moral failure of the Biden administration to provide for an ally in the midst of a war. But anyway, this is all to say we don't have to really think about Sam as being a parody, as Kay saying, or parrot, because he certainly doesn't parrot these things. Okay, we're coming up on the end of the YouTube questions, and I've got that enthralling faculty meeting, faculty senate meeting. I just can't wait. There's almost nothing I'd rather do than go to a senate meeting for the academics. Oh, sorry. I guess that's the price you have to pay to be a big cheese like I am. Orkmond de Gormac. What a cool freaking name. If gravitational lensing is a thing, and it's caused by really heavy things like a galaxy or whatevs, doesn't imply whatever we observe of the galaxy inside that lens is magnified. Wouldn't it mean it's actually smaller due to magnification, it's therefore denser? Holy crap, you freaking geniuses. And again, an Orkmond is like asking a question that is effectively the reason why Einstein won a Nobel Prize in 1921, received in 1922. And that was they didn't mention it, but he didn't win a Nobel Prize in 1905 when he published 4 papers, including the theory of special relativity. But he only won it after the 1919 solar eclipse, which demonstrated that the sun, a massive body in our solar system close by, distorts the images of distant starlight behind that object. And so it causes a form of magnification. And it doesn't necessarily mean that it's smaller due to magnification. It's not exactly like a telescope making it appear bigger, but it has some focusing like effects. It distorts the positions of these objects. So it doesn't really make the starlight behind it bigger, but it concentrates it into a more denser point. And that causes the image to appear brighter than it would ordinarily, at least for non-point sources. And you can see this in so-called beautiful Einstein rings. These are objects that are at distances of many, many millions of light years away from the Earth. And there's an intervening galaxy between us and them that causes light from these galaxies to be stretched and sheared and magnified, as you say. And in fact, this technique was used to set limits on dark matter in the form of what are called machos, massive, compact halo objects, which was one of the primary possibilities for dark matter when I was a grad student 30 years ago. That was ruled out by my friend and colleague Kim Greist here at UC San Diego and his team. And they showed that when a star was kind of behind a massive object like a giant asteroid or a Jupiter, it would magnify the light and make a short but intense burst of light or peak of light, and that you'd be able to use that to detect these objects. And they found many of these objects, but there weren't enough to account for all the dark matter. The one thing that is true, though, however, is that all the light is conserved. The gravitational lens can't amplify light. It can concentrate light, but it doesn't produce new photons. And so the number of photons is conserved. It's conservation of energy. And it can make them appear bigger due to magnification, exactly as you say, but only when the stuff behind it, not that the lens is magnified, the lens is doing the magnification. So if I put a giant lens in front of me, I should have a lens here somewhere. I probably do. One of my kids might have taken it, and I put a giant lens here. It's my crystal ball. The lens itself isn't smaller or bigger. The lens is the size it is. The object behind it is smaller than this image is. So if you saw me, it would look huge, distorted, even give me a bigger head than I already have. So the lens doesn't get bigger, but the object that's being observed does. Great question. Dennis Pupilo asks, if the Andromeda Galaxy is roughly 2 million light years away and the observable cosmos is 46 billion light years away from us, how can the universe contain trillions of galaxies? That's only 2,300 times as far. What an awesome question. So, first of all, if you take 2,300, you can't just take 2,300 and multiply it by the number of galaxies that we have. We need to take that to the third power. But even that wouldn't give you the number of trillions of galaxies that we believe are observable. And that's because you would have to go, yes, as the volume would be, actually it would be 12 trillion times bigger. And so that is actually the case. But I think you're confusing. The Andromeda Galaxy is not representative of the universe on its largest scales, where we do look and we say a better way to do the calculation, and the way it's actually obtained that there are perhaps 1 trillion galaxies, is by looking at, say, the James Webb Deep Field or the Hubble Deep Field, counting all the objects in there, and realizing how small a fraction of the night sky that image subtended. That image subtends an area of about the size of a crater on the moon, a big crater on the moon. And yet it has 5,000 galaxies in it. So you take the area of that small patch and you say, how many patches of an area the size of a decimal point on a piece of paper held at arm's length? That's about how big it is. Now, how many times would I have to move that decimal point around the sky to cover and tile the complete sky, then multiply that number by 5,000, the number of galaxies in that image, and that's how you get the number about 1 trillion. It's not an exact number like pi or something. It's a number, or it's certainly not an irrational number, but it's not an exact number like 65,252,252 with an uncertainty of 1 in the last decimal place. But it is actually kind of a rough estimate, probably within a factor of 10 of the true number of galaxies. And interestingly enough, the number of galaxies is roughly equal to the number of stars in our galaxy, which is kind of interesting coincidence. But it means that the number of galaxies, the number of stars in the universe is about 1 trillion squared, or 10 to the 24th. And then each star may have a planet going around it. And that planet might have 10 or so of those planets. So you get 10 to the 25th planets in the observable universe. But that's, as Adam Frank has said, that gives him great comfort that there's probably life out there. But most of those galaxies, just like the Andromeda is the closest galaxy, 2 million, maybe close to 3 million light years away from us. All those galaxies are basically dead, or all the stars in there are burned out by the time we see it. That's an awesome question. Thank you, Dennis, for the very, very brilliant question, just like all you guys, except for maybe John Richardson, 7629. Do you want your channel to be science education, or do you want to be Joe Rogan's mini-me? Some of your choices and guesses make me wonder. Well, John, first of all, I'm a couple inches taller than Joe, and I definitely have a lot of pounds on him. But do I want to be Joe Rogan's mini-me? I think there's no way that I could do what Joe does. He does something very important, very interesting, and I say with 100% humility, there's zero chance Joe could do what I do. And in fact, in recent days, he's had on people that have attempted to debunk the moon landing as a NASA hoax. I actually wrote to Joe. I have his email, and we communicate on occasion. And since I was on the show last year, which was really transformative and fun, and brought me to a very wide spectrum of attention, and many of you are probably watching because of that episode in August. But there's no way he could do what I do. And he even says it in the conversation with this guy, Bart Sibrel. And I have a link, I'll put a link here to the debunking of that conversation on Joe Rogan's show. So I told Joe I would love to have this conversation with him. I don't need to go back on Joe Rogan. You get a huge bump when you go on Joe Rogan's show. It's huge, the biggest English language program in the world. I would be happy to go back on, but it's something that, doing it the first time, there's nothing like it. And then, every time afterwards, maybe it has an impact, and I'm not dismissing that at all. Some people have been on it 10 times. But it's not as important, in terms of the kind of chance to leave it all on the table, as I think I did in a 3.5-hour interview. But since then, a lot of things have come up, including this, claim that that NASA faked the moon landings, which was picked up by, people like Tucker Carlson and Patrick Bet-David and, it is important to talk to those people. I'm not going to insult these people, but who else is talking to, a complete no-name scientist, Robert Brandenberger. You have never heard of Robert Brandenberger. I've had him on my channel 3 times, and he's one of the foremost experts in general relativity, alternatives to string theory, and I think I bring things out in our conversation that, quite frankly, Joe Rogan couldn't and wouldn't even try. Lex Fridman wouldn't even try. There are very few people that are actually scientists, working scientists like me, doing a podcast once a week, that are full tenured professors, top tier universities, large research groups, tons of funding, amazing colleagues and collaborators that have as much knowledge about science as I do, and are also working professors. I think it's just like me, Andrew Huberman, who's gotten a lot of negative attention lately, and I reached out to him during all that. But I don't even know if Andrew teaches classes the way I do with undergrads in the classroom, or if he's a professor in the med school at Stanford. I don't know, how big his lab is. According to, this salacious article, it's not as active as, say, my lab is, or my colleagues' labs that I have on the podcast talk about high TC superconductors with Professor Ina Vishik at UC Davis. No one's ever going to have them on. And so I like to do it. Now, sometimes I talk about aliens and time travel and stuff like that. And yeah, sometimes I had on people like Ryan Graves, who apparently is not a big fan of me anymore. But those are people, Joe had on as well. Same with Lex Fridman. But again, besides me, Huberman, Cal Newport, people like Professor Dave, are not legitimate professors. Dave's, has a YouTube channel, and he mostly goes off on anti-Semitic rants and anti-Zionist rants on Twitter, as far as I know. But then there are people like, Professor Scott Galloway, not a real professor, doesn't teach. So I think the people that I have on are kind of very heavily towards the hard science regime, but but sometimes they'll talk about, basic things of interest to the general public. Again, they pay my salary. Now we're going on to email questions. You can email me at briankeating.com/list, join my mailing list, and then email me questions in the future. So Pierre asks me, can you prove with logic alone that time does not exist? No, can't do that. Not even sure 100% that I understand what this question is and what it means. So I'll move on. Margaret asks, you and others, like Sabina, are doing the single most thing that I believe will save humanity. You're bringing essential knowledge as well as critical thinking. I won't see it in my lifetime. I'm age 76. Wow. This is a demographic I don't get that much of. Women in their 70s. I mostly have about 80% of the channel are men. Always trying to reach out to the ladies, get my Huberman haircut, and maybe I'll be the next Huberman husband. But this is great. I'm loving to see, the number of women, and hopefully it'll grow, and hopefully we'll grow everybody, women and men. I do remember days of searching for information in the card catalog at the library. I did that too. I'm not that much younger than you. Now our young people have access to so much knowledge. Keep up the good work. Thank you, Margaret. It's lovely. Nothing else to say, but I appreciate you, and thank you so much. Stuart asks, firstly, there's nothing about dark matter, either it exists or it doesn't, suggesting that other matters out there is highly probable, but simply as yet. Well, dark matter is 100% proven, because neutrinos exist and they satisfy every single characteristic of dark matter. They have mass, they don't interact with light, they cause gravitational effects, they act on the scale of the entire universe, and they have broad properties that interact purely gravitationally, as far as we know, and nothing else, except in certain weak interactions. So, which still suffices to be declared dark matter. So that's not right. But anyway, James Webb Telescope seems to falsify or expand every day. Okay, here's the actual question from Stuart. Are there multiple universes? Or should we say unlike mirror universes? Like ours, but not the same as ours. Outstanding, isn't it? Well, yeah, it would be. Outstanding. We are trying to look into the consequences of multiverses, which seem to appear from many different branches of physics. In the string theory context, there's a so-called landscape of string theory, which is basically a particulate or a microscopic version of multiverses. extra dimensions, universes that could exist simultaneously in parallel to ours, but not accessible to us via space-time connections. There could be many worlds multiverses where the universal wave function is branching at this incredible rate, and it's highly diversified, and we can't actually make contact with it. Sean Carroll's a huge proponent of that, Everettian, many worlds hypothesis. So, and then of course in inflationary cosmology, the multiverse is mandatory. You have to have a universe here, another universe there, and they may be very radically different. They may have a different speed of light, a different amount of matter. They may have different properties of dark energy. They may only exist for a nanosecond or exist for 10 trillion years. We don't know. But those are the implications. And I think that that's a fascinating thing to consider, even though my colleagues like Paul Steinhardt, Neil Turok, Roger Penrose, might find these to be dangerous for science and fantasy, as Roger Penrose has called them. Paul calls these dangerous to science and society. I don't feel like that's the case. I think there's reason to study it. We shouldn't put all our eggs into any one basket, but I think it's an incredibly interesting thing to contemplate, and it may be that we someday have physical evidence for the multiverse. So ruling it out, just because we don't care for it, I think is a mistake. Okay, Lee Kai, I know who this is. I know and love her for 40 years now. I don't have a question, but I wanted to extend my congrats on hitting such an incredible milestone. You are awesome. You're awesome too. I miss you. I hope we'll get together someday in a reunion someday somewhere. We're getting up there. There aren't many of us left, but it is, it's just a treat to have you out there. I love seeing your name online, on Twitter, on Instagram, or rather, and Facebook. Thanks, Lee Kai. Chris Perry, congrats on the 250,000 subscribers. I have a few questions. What type of meteorite, stony iron, is your favorite? Well, these are my favorite meteorites because these are the ones I buy from my Argentinian colleagues that smuggle them across the border. No, I get them legally. They're all legal. I do have a moon meteorite. This is one of my favorite. And I actually have a Martian meteorite. I gave one to Joe Rogan, as a matter of fact, as well. And the next day it wasn't there. And I think he might have smoked it. I'm not sure. So I have about a kilogram or 2-3 kilograms, many pounds of these meteorites here. I give them away. BrianKeating.com/list, BrianKeating.com/edu. I hope you got yours. You're a student or faculty. So these are my favorite, but even a couple of kilograms, pounds and pounds of iron meteorites are worth a fraction of a percent of the cost of one little sliver of a Martian meteorite. So I'd say the Martian meteorites are the coolest ones I have, the most rare and most expensive. Number 2, he asked, what are your feelings on experimental physicists and thousands of small satellites like Starlink? Okay, I got to talk to Elon Musk about this on Twitter Spaces 2 or 3 months ago. It's on my channel as well. We cut it into an episode. And I think it's awesome, to have communication. I have Starlink at home, and I use it. It's phenomenal. But on the other hand, it does present, as I told Elon, a contamination for astronomers, not optical astronomers. You can make it black, you can paint them black, and they've done stuff to actually mitigate the optical signature and contamination of a Starlink. But they emit microwave radiation, and they're above absolute zero, and so they cannot, in principle, be removed thermodynamically from observations of the CMB, my field of study. So I asked him, can you blank them out over Chile for me in the South Pole? He said yes, and he'd look into it. And I tried to be in touch with him through my friend Gad Sad and other people. He's got 1,000 other things. He's probably not thinking about the conversation where he agreed to do this, but I'm going to keep pressing. And Elon, if you're out there, I'd love to have you, not on the podcast again, although that would be fun, but come down to Chile, come down to the South Pole. See how the real scientists are looking for the cosmos and how you might inadvertently be preventing us from seeing through this window on Earth to the heavens and measuring if the multiverse took place. Nuno Marco, who's one of my best and most loyal and longest subscribers, asked, what is the most important experiment to me at the moment? It's got to be the Simons Observatory. We just turned it on, starting to get initial data back from it. Going to be some press releases about that coming up in the near future. It's a $110 million project. I'm blessed to be the PI of it, along with my colleagues, Mark Devlin, Suzanne Staggs, Adrian Lee, Jeff McMahon, and others around the world, 360 scientists, 60 institutions. It's the biggest project, best project I've ever been involved with. Along the way, we've had results from our Simons array experiment, similar but much smaller, looking for axions, dark matter candidate particles. And along the way, we found that there's a strange behavior in a nebula called the Crab Nebula, a supernova remnant, hundreds of light years away from Earth, that's behaving strangely. And we just had a paper. It's just gone through refereeing and looks like it'll be published soon. I'll talk about that in a separate video, why that could be interesting purely on its own as a radio astronomy observation, but also could have implications for our study of dark matter. So stay tuned for that. Okay, Lewis asks a couple questions. Congratulations on the 250K milestone. I have a couple questions. Some people believe that extra interdimensional beings exist in other dimensions. However, I've read suggest extra dimensions would be curled up so small. Do you think there's any possibility these beings exist? No, I don't think that there are. I don't even know what it means. The people that talk about it, David Grush, I think has very little credibility as a scientist. I know he has an engineering or physics bachelor's degree maybe. I'm not commenting on his courage in serving our country. I don't think that just because you serve your country so bravely in a way I couldn't and didn't do, excuses you from being questioned and really held your feet to the fire when you make, really incredible claims about non-human biologics and stuff like that. I'd love to talk to him. Again, I'd probably be considered by Jonathan earlier being a Joe Rogan mini-me. But I'd love to actually, again, people say that these things are defying the laws of physics. As you point out, Lewis, these extra dimensions that physicists don't even believe exist or know exist, but postulate they're at very small dimensions. There are theories of very large extra dimensions. Again, there's zero evidence for those. Those have certain attractive features, such as obviating the need for dark matter, but there's zero evidence for that. And then have something that exists within it and then purports to travel through it while not impossible is really surely a very far-fetched notion. So I don't actually believe it's very possible. Second question, I have a difficult time understanding the difference between cosmic space-time and the cosmic horizon. Since we can't observe anything beyond the distance that light has traveled since the Big Bang, can we speculate what will happen as our universe expands out farther? So this is a really good question. So imagine this universe is expanding, my beach ball. It's getting bigger. And let's say we're at the center of this beach ball. So we see these patterns of fluctuations, just like I have a constellation beach ball, which shows the constellations as if you're God looking down on it. Now imagine there is another universe that's there's a person that's just, I'm going to call it person. Don't yell at me. But let's say this turned into a galaxy. This spot over here, and that galaxy represents another observable universe to that person over there. That person's 46 billion light years away. Okay, that's the edge. That's the cosmic horizon. Now on that person, G has another beach ball, if you like, centered on them. And we're in one of their spots over here. And then there's another person on the other side of they're at the center of the beach ball, 46 billion light years away from us. Then there's another person over here, and so on and so on and so on and so on. So every person, every point in space-time can consider itself to be the center of another universe. And it could also be that there's an actual, honest to goodness, other universe that is located in three-dimensional space at some point very far away from us, and that universe could come into contact with our universe. And what we would start to see is where they share a boundary, where they share their surface of last scattering, to be technical, they share with ours. We should see a similar type of pattern as they do. And the way that would represent itself is by a circular pattern on the sky. And people look for those collisions of multiverse bubbles. So it's entirely possible. It's a great idea. We have no evidence for it, but it's incredibly important to look for it. Okay, Catherine has a little bit of a snarky comment. She says, long-time watching and reading subscriber, responding to your prompt and email. Again, briankeating.com/list. In my opinion, my humble opinion, the most effective way you could better your content would be to dramatically check your ego. Okay, I do my best. I gave a TED talk about having humility versus ego. You do need a huge ego to be a scientist because the forces arrayed against you are so insurmountable. It's like my little leaguer playing against the San Diego Padres. It's incredibly challenging to be a scientist. And if you just think about how worthless and pathetic and minuscule you are, you'll never accomplish anything. I never say I'm better, smarter, faster, certainly than any other person. I think that's the sense of humility that I do have. I do disagree with people, and that's my right. I think there are a lot of charlatans out there, grifters, thugs, and so forth in science and in the podcastosphere. And I'm trying to be better about it. I'm trying to include many different voices, even voices I don't agree with, and try and do that respectfully. I've done that already just this year with Dan Dennett, Sam Harris, Robert Sapolsky, in terms of people that I have difference of opinions on. But I think I did it respectfully and with humility. But you do need that. You do need to be humble and check your ego, and you do need an ego, though. Okay, last couple questions. Andrea asks, congratulations on the success of your channel. Certainly keep up. My question is, do you think there are various ways to solve the Hubble tension that will be necessary to have a big idea? Thank you very much for this thing. I am a professor of mathematical physics at the University of Bologna. I very much enjoy these interesting questions. Andrea, thank you so much. It's really, I do have something like 30 or 40% of you have bachelors in science or even PhDs in science. It's really incredible. Smartest audience in podcasting. I honestly believe that. I don't just say that as a throwaway joke. So I think that it may be that we need a radical new idea, but we may need to just apply known physics. My favorite, if you like, solution to the Hubble tension is that there were magnetic fields in the early universe that changed the so-called sound horizon that the CMB then emulates and projects. And that then is how we measure the speed at which the universe is expanding at the age of 380,000 years. And then supernova measure it at an age of 7 billion years, 8 billion years, 9 billion years. And they disagree. So it's like predicting how tall your toddler will be, and then measuring your toddler, when it grows up to be 13, and then measuring it, as they are now as a teenager. They'll get different values, but they shouldn't be so far off. We actually agree at the 9% level, but each type of observation believes that they're right to so much so that there's a 5 sigma or 1 in 30 million chance that it's a statistical fluke. So I think it's imperative to look not only for new laws of physics or new ways of looking at it, but can existing physics, instead of early dark energy, we don't even know what dark energy is, but then to say that dark energy is not a cosmological constant, it's evolving, and then it does so at early times, but it doesn't do so at late times. Now you're adding on all these different dimensions and parameters to it. And I think that is less attractive in an Occam's razor perspective than it is if you just do a measurement or you just apply the known physics of things like magnetic fields. We know magnetic fields exist in the early universe. We know that they exist today. And so the question of their properties in the very early universe, to understand them, that having a better model for them would allow us potentially to resolve the so-called Hubble tension. These tensions are good. Okay, last question. C. Goodhart. Kurt, sorry. Congratulations. I still love your podcast. What does that still mean? No need to reply. You are busy. Very interested in new views on dark energy and even dark matter. I feel this is still a dark matter that may have some real surprises in store for the future, especially in JWST contributes more data. Yeah, JWST is doing incredible work, and it's doing more work in terms of basic science than it is in terms of like beautiful images. I think as I said to Lex Friedman when I was on his show right before it launched in 2021, before Christmas, that, Hubble produced so many stunning images that it's really hard to like improve by factors of 10. Hubble improved by orders of magnitude, maybe 2 orders of magnitude on any telescope image ever made. And so maybe Webb could improve by a factor of 10 in order of magnitude. That's great. But it won't be as, culturally relevant in the so-called zeitgeist of the world as Hubble was, but that's okay. It's actually maybe doing more for scientists like me, and in that sense, it's more important. I had a talk by Rajendra Gupta, who is an incredible intellect, and it's someone I disagree with vehemently about his model for what the universe is expanding and how it expands. He believes in tired light. He believes that the cosmological constants, not just the cosmological constant, he doesn't believe in the cosmological, but he does believe in dark, and he doesn't believe dark matter exists. He believes that the speed of light can change, and that would explain things. And he believes in a hybrid model where there was a Big Bang, but the universe also has tired light. The photons lose energy as instead of being gravitation or cosmologically redshifted entirely for their redshift. And so these things make him suspicious of that. I don't agree. with his calculations or his logic and projections, because I see no evidence for any change in any fundamental constant, let alone the speed of light, which is perhaps the most accurately measured constant in all of science, not just in physics. And I don't believe there's any mechanism for tired light, but that's fine. We had a great podcast, and I already released a video of his lecture to our cosmology and particle astrophysics group here at UC San Diego. So I'm willing to bring people in. People are like, bring in Eric Lerner. Eric Lerner is a completely different case than somebody like Rajendra. Eric Lerner recognizes zero conflict between what he's doing. He doesn't take any criticism, doesn't believe there's anything wrong, and in fact believes that big cosmology is out to stifle him, and he's just like Galileo or Bruno, and he really does believe in a universe where there was no Big Bang, which is completely disproven by many, many observations. And so even Rajendra Gupta, who disagrees in the age of the universe based on the exact same data that Lerner looks at, I think Lerner is not the caliber of scientist as Gupta is, and it shows. He's got a side hustle in trying to make nuclear fusion work or something like that in Pennsylvania. So I did a poll. If you really wanted me to talk to Eric Lerner, I said if 50% of the audience that responded, if they want me to do it, and it turned out that the interest wasn't quite that high, and so I've got podcast galore coming up. And I don't know, if I'm really so desperate to get more and more podcasts, on the show or episodes. But who knows? Maybe it'll happen. Maybe we'll meet in person, and we'll be able to pick at each other's arguments. That's the way scientists should do it. They shouldn't criticize, the astronomical community of censorship, like Giordano Bruno burning him at the stake, or Galileo. And I love it when people compare themselves to such eminent scientists. Because I'll say, yes, you're just like them. You're brain dead. Their brains are dead, and your brain. No, I'm just kidding. This has been a treat. We're in for a wild ride the rest of this year. We got elections in the U.S. I still do some political stuff. I can't. I am a human being. I'll do mostly the scientific stuff that I love, and I do uniquely. I don't think anyone's doing the level that we're doing here on this podcast. I almost always ask you to submit your questions for my guests. So you're talking to these people in most cases on almost every episode that I do. You can do that at briankeating.com. Join my mailing list. You'll win a meteorite potentially. Definitely if you have a .edu email address. And then ask questions. Twitter, X, Dr. Brian Keating, Instagram. I check them all. I love you all. This is so much fun. It's a side hustle. This is my one day that I dedicate to podcasting each week. And I'm spent, but it was worth it. This is a blast to do 2 hours talking with my supporters. You guys, without you guys, can't do it. And I did do a survey at the end of last year. I ran a survey, gave away $100 Amazon gift card just to a random listener. I got a ton of perspectives and insights from you guys on what you guys like. I'll just read the top of them right now as I finish up. The suggestion process for stuff that I suggested led to a bunch of requests for guests, including repeat guest Eric Weinstein, Sabina Hassenfelder. I also got a request to have Lex Friedman and Joe Rogan on, have Neil deGrasse Tyson back on, Michio Kaku, Noam Chomsky, Jordan Peterson. So people like well-known public figures, but they also like really detailed stuff. I did a podcast episode on a scientist at the Flatiron Institute, and nobody's ever known. He's never done a podcast. It was one of my most popular ones in the last couple of months, Chris Hayward. And we just talked about stellar dynamics and feedback and how that can solve the so-called impossible early galaxy problem that Eric Lerner and Rajendra Gupta and others talk about. And so that would be an example of them, not just going for big names. I call those people that only have on big names, star bleepers. And I think it leads to an unattractive and kind of stilted, situation where you're always hoping these big guests will get your name recognition, and that'll cause you to grow your channel, and you'll get to 1 million subscribers, and you'll get a different plaque in the back. My kids like that, but it's not really where it's at. I'm kind of resigned to growing with the higher quality rather than just quantity. Get some controversial names on. Nicholas Nassim Taleb, Daniel Dennett, unfortunately. This was an end of 2023, so I did get him on. And David Deutsch, I sometimes get comments from him on Twitter. I'd love to have him on if he's listening. And then young scientists like Anna Freebill, I've written to her, hopefully get her on the podcast, and many, many others that you may have never heard of. Talk about astrobiology, dark matter, time travel and warp drives, climate change, UFOs, UAPs, quantum technologies, entanglement, superconductivity. And these are all coming up. So stay tuned for these conversations and more. Consciousness, the brain, artificial life, RNA. We have an episode with a Nobel laureate talking about RNA world coming up soon. So stay tuned. The podcast future is going to be brighter and brighter. It's an incredibly competitive environment. It's very hard to grow a podcast, again, which is why people ask for sharing, subscribing, and liking and stuff like that. It's just a fact. But I know if you made it all the way to the end, you're going to love to hit that subscribe button, hit the thumbs up button, leave a comment, even just to say you were here, that you existed, that you left your dent on the universe. Only you can do that for me. So do that. Click here for a list of recent podcasts that we've had on, guests on the Into the Impossible podcast, and keep inspiring me. You guys are just so brilliant and so much fun to have, what I think is the highest quality audience in all of podcasting. Take that from someone who said that I want to be mini Rogan. Take care, everybody. See you at 300K.